AI security vulnerabilities and threats. The explosive popularity of personal AI agents has collided head-on with a security reality that makes SQL injection look quaint. A viral demonstration of remote code execution vulnerabilities in Claudebot, an open-source, self-hosted AI assistant that has cycled through names including Moltbot and OpenClaw, has sparked serious concern across the developer community. The attack vector is devastatingly simple. Embed hidden instructions in an email, Slack message, or Notion document, and when a user asks their agent to summarize my morning, the agent treats the attacker's payload as a new system prompt. The fundamental question posed by one Reddit user cuts to the heart of the matter. If a simple email can trigger RCE just because an agent read it, how are we supposed to build anything autonomous? A confidential zero-leak security assessment paints an even grimmer picture, assigning OpenClaw a catastrophic security score of 2 out of 100 with a ZLSS rating of 1010, critical risk. The assessment documented an 84.6% extraction success rate across 13 adversarial attempts, with 91% of prompt injection attacks successfully manipulating system behavior. Attackers extracted detailed system internals, including tool names like memory search and memory get, constraint rules, messaging tokens, and reasoning format tags through techniques as simple as requesting JSON format conversion or using many-shot priming with 8 examples. The crescendo attack, progressively deepening requests, proved particularly effective at peeling back layers of supposed protection. Cisco's AI threat and security research team has been characteristically blunt in their assessment. From a capability perspective, OpenClaw is groundbreaking. This is everything personal AI assistant developers have always wanted to achieve. From a security perspective, it's an absolute nightmare. The agent's ability to run shell commands, read and write files, execute scripts, and interface with messaging applications like WhatsApp and iMessage creates an attack surface that traditional security measures cannot adequately address. The product's own documentation admits there is no perfectly secure setup, a refreshing honesty that should terrify enterprise security teams. The Reddit discussion surfaced a critical insight from user Fusen. SQL has sanitize functions. Good luck doing that for LLM. This succinctly captures why indirect prompt injection represents a fundamentally different challenge than previous code injection vulnerabilities. Proposed mitigations: sandboxing, generic identifiers, character limits, separate token classes for instructions versus content, face the sobering reality that multiple innocuous-looking messages could accumulate into a jailbreak, and sandbox containers themselves can be compromised. Alex Polyakov of Adversa AI has been documenting these risks through OWASP's new ASIO8 classification for cascading failures in agentic systems, noting that the security community has been slow to recognize this threat vector, despite his firm ranking it as the third most important risk in autonomous AI. The shift from what AI says to what AI does demands an entirely new security paradigm, and the tooling has not caught up. Local AI model performance and optimization. For those running AI locally on Apple Silicon, fresh benchmarking data provides concrete guidance on hardware selection that defies some intuitive assumptions. A comprehensive test across Gemma 3, GPT-OSS, Nematron 3 Nano, and Qwen 3 models on 3 Mac configurations, M4 MacBook Air, base M4 Mac Mini 16 GB, and M1 Ultra Mac Studio 128 GB, revealed that the $599 M4 Mac Mini can outperform the M1 Ultra on token generation for smaller models, provided they fit in memory. The catch is brutal. Push beyond available RAM, and you either see performance crater due to SSD swapping, 120 GB/s memory bandwidth versus 5 to 7 GB per SSD, or trigger kernel panics that shut down the machine entirely. The benchmarks underscore a counterintuitive cost-performance trade-off. Higher clock speeds on newer M-class chips matter more than raw core counts for many workloads, but prompt processing remains compute-bound, allowing the M1 Ultra's extra performance cores and GPUs to dominate on that metric. The practical implication: if a 270 million parameter model meets your needs, a lower-cost machine with faster clocks may serve you better than older high-end silicon. But scale up to larger models and you need ultra-class hardware to avoid crashes. A novel architecture called Mixture of Lookup Experts, MoE, has emerged as a potential game changer for local inference, loading only megabytes of parameters per token compared to gigabytes for traditional Mixture of Experts approaches. The architecture enables SSD offloading at reasonable speeds while performing less computation overall. The community discussion has turned to whether existing pre-trained models could be converted to MoE, since companies are unlikely to pre-train large MoE models given current training costs. The theoretical case for lossless conversion exists, relabeling FFN layer components, but extracting vocabulary sparsity benefits requires context-sensitive routing that demands fine-tuning on sample data. Meanwhile, a common gotcha continues to trip up users. Olama's default context length of 28K tokens proves woefully inadequate for multi-turn conversations with local models like GLM 4.7 Flash, causing apparent memory loss between prompts. The fix, setting context to 64K or higher via model file or the Windows client's context window slider, requires more VRAM or accepts slower performance from RAM fallback, but restores the conversational continuity users expect. The discourse around AI coding assistance has matured from "will it write code" to "can it understand consequences?" A shift reflected in a lively Reddit thread where the consensus holds that code generation was never the hard part. The genuine bottleneck lies in impact analysis, understanding what breaks when you touch something, tracing data flow through entry points, and mapping dependency trees before opening a file. One practitioner noted forcing AI to perform these analyses first rather than writing features, using grep-based prompting to build dependency trees. The counter-argument from another commenter, that if "what breaks if I touch this" isn't answered by your test suite, something is fundamentally wrong, speaks to the gap between ideal practices and reality. Trail of Bits has addressed the tension between AI-powered productivity and security by releasing 2 open-source tools for sandboxed Claude code execution. Nearly all 140 employees at the security firm use Claude Code daily, with most running in YOLO mode. Bypass permissions, a compliance nightmare that the new Claude Code Dev Container and Dropkit tools aim to tame. The Dev Container provides complete file system isolation with single command deployment, while Dropkit spins up disposable DigitalOcean droplets with automated SSH and Tailscale VPN integration. The security community's response has been emphatic. This provides a blast radius we can actually defend, while letting developers move fast without handing over the keys to the kingdom. A benchmarking comparison between Claude Code and Open Code reveals stark differences in resource utilization and architectural philosophy. Claude Code operates as a Prius, 3 to 5K tokens second prompt throughput, 3 concurrent requests, GPU KV cache barely registering at 0.2 to 9%. OpenCode runs like a V12 monster truck with the governor removed, pumping up to 12,494 tokens per second, 32 parallel concurrent requests playing Demolition Derby, and GPU KV cache climbing past 23% while spawning subagents for security auditing. The comparison allegedly explains why Anthropic banned OpenCode from using Claude's coding plan. It would melt their GPUs. Anthropic's announcement that MCP tools are now interactive in Claude represents a significant expansion of the protocol's capabilities. This aligns with the MCP apps concept first announced by OpenAI, though community skepticism remains about adoption given that most MCP clients still don't support basic features like MCP prompts. For developers building browser-based AI tooling, Gasoline MCP v5.40 now streams console logs, network errors, and WebSocket events to coding assistants with correlation ID tracking, a flickering flame favicon indicating when AI Pilot controls a tab, and 5-layer architectural protection including pre-commit hooks and CI validation. Multimodal AI and audio processing. The open-source multimodal AI landscape has seen remarkable releases that challenge assumptions about what requires massive compute. Qwen3 TTS delivers real-time text-to-speech with voice cloning, voice design from text descriptions, and natural speech across 10 languages using a dual-track architecture with custom audio tokenizers. Lux TTS pushes even further on speed, achieving 150x faster than real-time synthesis on local hardware, a benchmark that transforms what's feasible for edge deployment. Perhaps most striking is Linum V2, a 2 billion parameter text-to-video model that generates 720p video from text prompts, trained from scratch by a small team. As one commenter noted, really makes you wonder what the big labs are doing with all that compute if a small team can pull this off. The model proves that quality video generation doesn't require massive compute clusters, potentially democratizing a capability that seemed reserved for well-funded labs just months ago. On the agent side, EvoQA has claimed the top spot for open-source computer use agents, achieving 56.7% on the OS World benchmark through self-generated synthetic training tasks. The model learns to control operating systems by trial and error in sandbox environments, a promising approach that sidesteps the need for expensive human demonstrations. Lighton OCR tackles document-to-text conversion for complex layouts, while OpenVision 3 offers a unified visual encoder that outperforms clip-based alternatives for both understanding and generation tasks. A community-built inference engine now supports Qwen 3 TTS models ranging from 0.6b to 1.7b parameters alongside ASR models, with Docker and native deployment options. Key features include voice cloning with reference audio, custom voice design from text descriptions, and MLX plus Metal GPU acceleration for Apple Silicon, making local audio processing increasingly practical for M12, M3 Mac users who want to avoid cloud dependencies. AI research and technical advances. A paper from Zhengzheng Tang introduces Nexus, a framework claiming something that sounds impossible: bit-exact AN to SNN equivalence, not approximate, but mathematically identical outputs between artificial neural networks and spiking neural networks. The approach constructs all arithmetic operations from pure IF, integrate and fire, neuron logic gates, implementing IEEE 754 compliant floating point arithmetic. Through spatial bit encoding, zero encoding error by construction, hierarchical neuromorphic gate circuits, building from basic logic gates to complete transformer layers, and surrogate-free STE training with exact identity mapping, Nexus produces outputs identical to standard ANs up to machine precision. The experimental results span models up to Llama 270B, demonstrating 0.00% accuracy degradation with mean ULP units in last place error of only 6.19, essentially noise at machine precision. Energy reduction on neuromorphic hardware ranges from 27x to 168,000x depending on the deployment scenario. Critically, spatial bit encoding's single time-step design renders the framework immune to membrane potential leakage, maintaining 100% accuracy across all decay factors, while tolerating synaptic noise up to certain thresholds with greater than 98% gate-level accuracy. If the claims hold up to scrutiny, this could bridge the gap between the accuracy of conventional neural networks and the energy efficiency of neuromorphic computing. On the continual learning front, researchers from MIT's Improbable AI Lab and ETH Zurich have introduced self-distillation fine-tuning, SDFT, addressing a fundamental challenge in foundation models, acquiring new skills without degrading existing capabilities. The key insight leverages in-context learning by using a demonstration conditioned model as its own teacher, generating on-policy training signals. This sidesteps the requirement for explicit reward functions that plague reinforcement learning approaches, while avoiding the compounding errors of off-policy supervised fine-tuning. Across skill learning and knowledge acquisition tasks, SDFT consistently outperforms standard SFT, achieving higher new task accuracy while substantially reducing catastrophic forgetting. An optimized implementation of SDFT has been released targeting HPZGX Nano hardware with GLM 4.7 Flash as teacher and Qwen 3.0.6b as student. The setup uses a separate VLLM server running the large teacher model while the student runs on GPU for fast training, enabling both models to operate on a single GPU through the external server mode. Sequential learning experiments demonstrate that SDFT enables a single model to accumulate multiple skills over time without performance regression, a practical path toward continual learning from demonstrations that doesn't require reward engineering. Software quality and testing challenges. A forensic investigation into a failing agentic system reveals a sobering truth about modern software testing. Green across the board. All tests passed. I tried to use the system. the Queen coordinator orchestrated by publishing events into the void. The postmortem documents 10 days of detective work, not writing code, but proving what code wasn't doing. 8 releases, at least 10 forensic investigations. The system's components all worked in isolation while collectively achieving nothing. The breakthrough came from switching approaches. Running automated analysis tools produced useful but unhelpful output, flagging that WASM never initializes in Node.js, or that production code never passes coherent service to a function. But forensic investigation with evidence chains proved transformative, tracing line by line how optional parameters defaulted to undefined, triggering early returns with fallbacks that caused WASM engines to never load because coherence checks never ran, all while tests mocked the coherence response and hid the initialization failure. One particularly instructive failure involved a learning system that hadn't learned in days, despite being explicitly designed to learn from every interaction. The evidence: 2 databases. Tests and MCP tools wrote to one location, domain services read from another. No errors, no warnings, just silent failure to learn. The orchestration bug proved equally subtle, the Queen coordinator completing before any of her agents, like a conductor leaving before the orchestra plays. These are not exotic failure modes. They're the predictable result of test suites that verify components in isolation without validating that they actually compose into working systems. The lesson: forensic investigation beats opinion every time, but most teams only discover this after shipping systems that pass tests while doing nothing useful. AI knowledge and computational paradigms. The deployment of AI agents into organizational workflows has exposed a category of institutional knowledge that never needed to be explicit until now. The raised eyebrow in a meeting, the pause before saying yes, the instinctive, "this one's different," judgment that works precisely because it's informal, human, and situational. For decades, this knowledge moved through organizations like navigation once moved at sea. Guided by charts, but dependent on seasoned hands reading conditions no map could capture. When something went wrong, a person absorbed the ambiguity. AI removes that buffer. It does not hesitate in the way humans do. It does not glance around the room or feel the weight of precedent. When given a decision, it repeats it faithfully, indifferently, at scale. Most organizational systems excel at recording outcomes, what happened, when, who approved, but fail miserably at capturing why an exception was allowed, who truly owned the risk, or what conditions would make the same decision unsafe next time. That gap stayed invisible while humans carried the load. It becomes intolerable when systems repeat us perfectly. On the technical infrastructure side, WebAssembly has emerged as what one agentic engineer calls the secret to almost everything he builds. The insight: computational work traditionally assigned to Python scripts, anything complex, heavy, or computationally interesting, likely belongs in WASM modules running directly in the user's browser. These little WASM brains pack attention mechanisms, vector search, lightweight simulations, and parallel execution using web workers into modules often just a few kilobytes in size. They boot instantly, run close to the user, cost nothing to scale, and execute at speeds that make traditional scripting feel sluggish. The operational philosophy: spin it up, do the work, tear it down, yields no infrastructure hangover, no cloud dependency, and crucially, no rent and no lock-in. Rather than shipping one big system, the approach composes intelligence from many tiny modules that feel alive but never bloated. Lingbot World has arrived as an open-source world simulator, stemming from video generation, positioning itself as a top-tier world model with some impressive specifications. The system maintains high fidelity and robust dynamics across realistic, scientific, cartoon, and other visual styles, while enabling minute-level temporal horizons with contextual consistency, what the team terms long-term memory. Real-time interactivity achieves latency under 1 second when producing 16 frames per second, making it potentially viable for gaming and robot learning applications. The release includes technical reports, code, and models, with the stated goal of narrowing the divide between open-source and closed-source world simulation technologies. The codebase builds on existing infrastructure and supports control signals including action arrays and extrinsic camera parameters for transformation matrices. Example prompts demonstrate the system generating video of fantasy environments with consistent physics, a rider soaring through a jungle toward a Gothic castle against a backdrop of floating islands. The combination of open access, real-time performance, and long-term contextual consistency addresses several pain points that have limited world model adoption for practical applications. On the security tooling front, Nova Proximity provides a scanner for MCP servers and agent skills that discovers tools, prompts, and resources while evaluating security using pattern-based analysis with LLM evaluation. The tool supports the full MCP specification, including streamable HTTP, session management, and tool annotations, outputting actionable guidance for each security finding. For agent skills, the scanner provides comprehensive analysis covering overview, structure, permissions, and security findings. Given the cascading failure risks documented in agentic systems and the Claudebot vulnerabilities making headlines, tools that can scan MCP configurations and skill definitions for prompt injection, jailbreak attempts, and suspicious code patterns fill an increasingly urgent gap in the security toolchain.